I'll just fall behind and you guys will do oh so well. Stephen, thank you for knowing that now we start filming. All right. So, are we good? We're filming? All right, so one more time for the friends at North Central and the folks at East End, the power rule. What does the power rule tell us to do?
Bring the
power down and reduce the power by 1. And then we also know the product rule for when I'm multiplying two functions together. The product rule says derivative of the first times the second plus the first times the derivative of the second. Good. Then we have the quotient rule. The quotient rule says low d high minus high d low, low. Good. Now we've got some other things coming your way, such as the extended product rule. The extended product rule is what you're going to do when you have 3 functions being multiplied together. That's right, because sometimes that's going to happen. Now, rather than calling it f of x and g of x, I'm just going to use the variables u, v, and w. U, v, and w are all functions. And here's what I would do. If what I want to do is find y prime, what I want to do is I want to think about multiplying 3 things together as actually multiplying 2 things together, because that's how the product rule works. So what if I group the things together and call this uv times w? Can everybody kind of see that as it's 2 things getting multiplied together? Well, what does the product rule tell me to do? It says take the derivative of what I have first times leave the second one alone plus leave the first one alone times the derivative of the second. Right? uv is what I'm calling the first, w is what I'm calling the second. Take the derivative of the first, leave the second alone, plus the first times the derivative of the second. So what?
It's a W or a smiley?
That's a W. Why on earth would I ever smile? W. Okay. Now, this is good, however, it's not finished because there's still some derivative work that you should do. The derivative work that you should do is over here, when you're taking the derivative of the product of u and v. How are we going to take the derivative over here?
Multiply u and v.
You're taking the derivative of a product. You're taking the derivative of u times v. And so that tells me take the derivative of the first, u prime, leave the second alone, plus leave the first alone, times the derivative of the second, multiply all that by w, and then plus uv w prime. Let's multiply this out. U prime v plus uv prime all times w? Well, isn't that the same as u prime times v times w plus u times v prime times w plus u times v times w prime? That's the extended product rule. Whoa. Hold back just for a second. Anybody see a clever way that you are going to keep this locked into your brain? Lewis sees it, Carmen sees it. Something clever that's happening here. Celeste sees it. I think LA sees it. LA, do you see something here? What do you see?
Well, you have UVW and like the prime looks like on the first part, you take prime of the first.
You've got the UVW and you're taking the derivative of the first part.
And then the second part, take it of the second one.
Then you've got the UVW and this time you're taking the derivative on the second one.
Oh,
and then UVW and you're taking the derivative on the third one. This is the extended product rule. This is what you would do if there were 3 terms. If not 3 terms, sorry, 3 things being multiplied together. The extended product rule says take the derivative of the first and then leave the second and third alone.
Plus the first.
Plus, leave the first alone. Derivative of the second. Leave the third alone. Plus, leave the first 2 alone. Derivative of the third. We got this under control?
Yes.
And I would imagine that now, like if I said, hey, there's 4 things that I'm multiplying together.
You'd cry.
No, we would be clever. Lewis, what would you do?
Multiply the derivative of the first times the second. leave the second, third, and fourth alone.
If it was 4 things, you'd take the derivative of the first,
Leave the second, third, and fourth alone.
leave the second, third, and fourth alone.
Plus
Plus,
the first one leave alone.
the first one gets left alone.
Derivative of the second.
Derivative of the second.
Leave the third and fourth alone.
Leave the third and fourth alone.
Plus.
Plus.
the first and two.
Plus the
two
first 2 get left alone. Derivative of the third.
Plus the fourth alone.
Multiply by the fourth.
Yeah.
Plus.
Leave the first 3
Leave
alone.
the first 3 alone.
Times the
Derivative of the fourth. Everybody good? Good. All right. Show me what you can do by taking the derivative of 3x squared minus 5x plus 2, the whole thing cubed. Know that there is deeper stuff here. There is always a method to the madness. It's not just madness. Aaron, you asked me something and I...
Oh, so it wouldn't be easy to play like that. That's pretty crazy. So we have to write this 3 times.
Yeah.
Time out. First
Alright, K prime, take the derivative of the first times the second times the third plus leave the first alone, derivative of the second, leave the third alone. Woo! Plus the first, leave it alone. The second, leave it alone. The derivative of the third. Ow, my hand hurts just writing all that. I
You don't
know.
have to.
Derivative of the first, leave the next 2 alone. Plus leave the first one alone, derivative of the second times the third. Okay, Celeste, give me something clever here.
You can just write 6x minus 5 times
6x minus 5.
times 3x squared minus 5x plus 2 squared. Like, all of it
3x squared minus 5x plus 2, the whole thing squared. That's a better way to write this first product, right?
Times three.
Times 3.
And the second product? And
The third.
the third product? So the best thing to do here is just have this 3 times?
Yeah.
Nice.
No.
There is always something deeper that I want you to see. Always, always, always. Nicely done. That's nice. Okay. All the friends are okay? All right. That brings us to something called the chain rule. The derivative rules are coming fast and furious today. The chain rule is what you are going to do when you have composition of functions. I'm saying composition because that is the proper fancy vocabulary word here. But composition just means a function inside of another function. Okay? You've got a function that lives inside of another function. Some people say it this way. The derivative of a composition function, you take the derivative of the outside function, leave the inside function alone, times the derivative of the inside function. So the chain rule says take the derivative of the outside function, leave the inside function alone, times the derivative of the inside function. This is for composition, a function inside of another function. Other people like to think of this as the mama and her baby. We're big fans of mama and the baby.
Are we?
Yet we are. The baby
Jewish.
is g of x. Because the baby lives inside the mama. At least for a little while. I know, you're not gonna miss my mama. Okay, we've got the baby, we've got the mama. Here's what the chain rule says for the baby mama people. The chain rule says take the derivative of the mama, leave her baby alone, times the derivative of the baby. So say it with me, the chain rule says?
The table says,
Take the derivative of the mama.
take the derivative of the mama.
Leave her baby alone.
Leave her baby alone.
Times the derivative of the baby.
Times the derivative of the baby.
Excellent. Tell somebody near you.
So you
Normal baby.
Baby alone. Times the derivative of the baby.
Stay with me. We're gonna get there. We're gonna. So like for a little like example, like maybe that we're gonna put over here on the side. Here we go. Let's say I've got some function. I don't know. Let's call it k of x, and I've got 3x squared minus 5x plus 2 the whole thing cubed. I mean, just like some random example that I just made off the top of my head here. It's totally weird. Totally weird. Is there an inside function and is there an outside function?
Yes. Or we can make one.
What's the inside function? The inside function is this guy here. This is your baby. This is g. 3x squared minus 5x plus 2. If that's the baby, then the mama is everything else. F of x would be x cubed. Well, what does the chain rule say? The chain rule says take the derivative of the mama. You guys know what the derivative of the mama is. 3x squared. 3x squared. 3 times of the inside here times the derivative of the baby, which is 6x minus 5. The derivative of 3x squared minus 5x plus 2. This is the baby. Ignore the baby for a little bit. Take the derivative of the mama, which if mama is x cubed, the derivative is 3x squared times the derivative of the baby, which is 6x minus 5. Which is exactly what we came up with earlier with this idea of the extended product rule. How's everybody doing with this? You okay? Carmen's like, I'm frazzled. All right, so if we've got the chain rule under control, and we're going to come back in just a little bit, let's see if you guys can do these first 2 examples. First 2 examples on page 15. And then we get another derivative rule coming your way. And tomorrow we've got like 5 derivative rules coming your way.
yeah.
Aaron.
Would you write it like this?
Almost. The derivative of something raised to the 1/2 power is 1/2 stuff. It's negative 1/2 power.
This is all to the
Right, because your mama. Let's not talk about that. Okay. Your mama is x to the 1/2 power. So the derivative is 1/2 x to the negative 1/2 power.
So I can do it.
Okay, there you go.
Oh, and then leave the 6x minus 5.
Yep.
Okay.
All right, friends. On example 1, what's the baby?
Baby 3x squared minus 5x plus 2.
Good. The baby is always the inside function of the mama. The mama is the square root of the stuff, right? So some people like to go off on the side and say, okay, what's baby prime? Baby prime is 6x minus 5. What's mama prime?
1 over 2 square root.
1 over 2 square roots of stuff. Right? If mama is the square root of stuff, then the derivative of mama is 1 over 2 square roots of stuff. Because remember, this is one that I said would be helpful to have memorized. Okay? So L prime just says take the derivative of the mama, but leave her baby alone, times the derivative of the baby, which is 6x minus 5. The best way to write this would be 6x minus 5 over 2 square roots 3x squared minus 5x plus 2. That would be the derivative. You don't have to write it this way, Aaron. If what you said was, I want to think of the derivative of the mama as 1/2 stuff to the negative 1/2 power, that's fine. You'll have 1/2 this
It's just
stuff.
easier to break down.
Yeah. Likely on a multiple choice test, you're going to see it this way. Is everybody okay?
Yes.
All right, so we can do this next one. And I'll take care of stickers here. Lewis, have you earned all your stickers?
Yeah.
And Andrew, all your stickers? Which two?
Product and quotient.
Product and quotient? Okay. So
Yeah.
Lewis, all the stickers?
Yeah.
Steven, did you get all the stickers?
Yes.
Okay. And Carmen, all the stickers?
Yes.
All right. So Andrew, we just need power rule.
Yeah.
Okay, it's all right. You're gonna get the power rule. Don't worry. For a lot of students, that is always the hardest one to get. That looks good to me. All right. Equation of the tangent line. Oh, we need a point and a slope. F prime. Let's see. F is stuff to the 100 power. Clearly, chain rule.
Yes.
Clearly, chain rule. Derivative of stuff to the 100 is 100. Stuff to the 99 power
Yes.
times derivative of stuff. I need derivative of stuff here, which is, what is that, 2x,
2x
plus
1/2 root x.
1/2 root x. The parentheses around the derivative of the baby is not negotiable. Put those parentheses because I need the 100 times all this times everything. My folks that forget the parentheses, what you're telling me is multiply by 2x and then add this guy on. I need all the parentheses. Palamon, what do you think? Are we done? Why not? Okay, so what are we going to do to find the equation of the tangent line at x equals 1? You're going to plug in what? Okay, so we're going to plug in 1 to f. 1 to f is 1 squared plus the square root of 1 to the 100. What is that, 2 to the 100 power? I don't know what 2 to the 100 power is. Sorry. I don't even care what 2 to the 100 power is. F prime of 1 is going to be 100 to the 99th power. What's this guy here? 2 plus a half. So I'm just going to write that as like 5/2 maybe. That's okay. That's your slope. That's the point. The equation of your tangent line, we're going to say L of x is 100 to the 99th power times 5/2 x minus 1 plus 2 to the 100th power. And I hope everybody's okay.
Oh, wait.
Taking, okay.
Just give me a second to process.
Taking the derivative, everybody was okay.
Yes.
Okay. I'd say that's probably worth 2 points. Plugging in the 1 to get the y coordinate for the point of tangency. Plugging in the 1 to get the slope. Hopefully everybody's okay. And now just writing the equation of the tangent line. This is all f prime of 1 over here. This is obviously 1. And this guy over here is what you get for f of 1. Okay. Here's what I'm really interested in. I'm interested in you guys being able to do example 3. In example 3, h of t is that function over there, which is really hard for me to see. That's, it looks like 2 prime, that's 2 with a comma that kind of got out of place.
Oh, I was like, what is this?
You're like, 2 prime! A is a constant. Now here's the thing. I want you to find h prime of t 2 different ways. One of them is obvious, I think. quotient rule.
That's all that equals.
The other way,
Chain rule.
think of it as a chain rule. I want you to show me that those are the same. I want you to see that you have options here.
It's just that. It's just that.
Wait, how do you get 5 over 2? Wait. Two plus. I don't know. How do you get it? Oh, okay, so yeah.
Wait. Then 2 or 3.
Wait, is that t to the fourth plus at squared?
No, it's AT cubed.
Oh, bummer.
Yeah.
Bummer.
It's so you just
At
gotta put, yeah, you just gotta put
cubed.
2.
So that's 3at squared.
Yes.
At cubed. 3at squared. 2 to the fourth, at cubed plus 2 the whole thing squared.
Yes.
Okay, my quotient rule people, is everybody okay?
Yes.
You could say
Okay. Chain rule. Steven, tell me how you see this as a chain rule.
G of x equals, wait,
What's the baby, what's the mama?
I mean, G of x equals t to the power of 4 plus a t to the power of 3.
Right, so the baby is all the stuff in the denominator, which means that the mama is 1 over stuff. And so the derivative of 1 over stuff, how does that work? The derivative of 1 over stuff, like derivative of 1 over x.
Oh,
Negative 1 over x.
It's negative 1 over
stuff.
stuff squared. So what is that? T to the fourth, at cubed plus 2 the whole thing squared. Promising. Right? Derivative of 1 over stuff is negative 1 over stuff squared. Don't forget the next part though. Times the derivative of the baby, which is 4t cubed 3at squared. So when you're done, you do get negative 1, 4t cubed 3at squared over t to the fourth, at cubed plus 2 the whole thing squared. And they're the same. Big takeaway here. Which way is better?
We don't know.
Doesn't really matter. Whichever way you see it. If you see it as a chain rule, go chain rule. If you see it as a quotient rule, go quotient rule. Just get there. What if you see it both ways? Great. Don't be like, which one do I do? Pick one. Pick one. All right, now I'm really curious to see what you guys can do. I never get to this problem in A, B. I'm always hopeful that we're going to get to it in B, C. Show me what you can do with this next one.
Wait, they have to learn this?
Of course they do. I'm sorry, they get to learn this. They get to learn this. Shut up.
Come back and watch the video.
They're gonna come to us so hard.
And we haven't even gone to the extended chain rule yet.
Yeah,
We're gonna fail.
No, you're not going to fail.
Wait.
We're going to visualize? Like a piecewise from
Yes, this is a chain rule problem.
I know how it sounds. I just said it like this. I already have it said it. X squared plus 1. X squared plus 1. X squared plus 1. Then setting up sort of like this root on the X squared plus 1. Yeah, the bottom line. I'm just going to get some wash.
If I could stop all the friends just for a second. Walking around, I've seen this on 2 different papers, and I'm not going to share whose paper I saw it on because I don't care about that. What do we think about this as the derivative? Does this work? If it doesn't work, why not? What's the mistake? 1 person? 2 people?
All on the right.
Celeste, what's the mistake?
They don't take the derivative of the baby.
Right. First of all, is this a chain rule?
Yes.
This is a chain rule. And the baby is the square root of x squared plus 1. And the mama is f. And so the chain rule says take the derivative of the mama, got it, leave the baby alone. But then what does the product rule, the chain rule say?
The derivative of the baby.
Take the derivative of the baby. I've got to go and take the derivative of the square root of x squared plus 1? How on earth would I ever find the derivative of something like the square root of x squared plus
X to
1?
the half power.
Yes, this is x squared plus 1 to the half power, but how am I going to take the derivative of the square root of x squared plus 1? David, what would you do?
Chain rule.
It's another chain rule.
Yeah, chain rule.
Here you believe? But no, I already used my chain rule coupon. No, you got more. So let's take the derivative of the square root of x squared plus 1. You're taking the derivative of square root of stuff. The derivative of the square root of stuff is 1 over 2 square roots of stuff times the derivative of the stuff, which is 2x. So we've got f prime of the square root of x squared plus 1 times 1 over 2 square roots of x squared plus 1 times 2x. All that is g prime of x. And you're not done yet.
Wait. I'm off.
David, why are we not done yet?
We need to find g prime of 0.
You need g prime of 0. G prime of 0 is f prime of 0 squared plus 1 is 1, so f prime of 1. 1 over 2 square roots of 1 times 0. So the final answer?
0.
0. G prime of 0 is 0. Nice job. Everybody okay?
Where do you get the 2x from?
Where did I get the 2x from? When I was taking the derivative of the square root of x squared plus 1, it's a chain rule. Derivative of the square root of stuff, 1 over 2 square roots of stuff, times derivative of the stuff.
Oh, you did the derivative of x squared plus 1 to the root.
Yep. Everybody good? This ddx notation in the middle of a problem, strongly encourage that you start adopting this. Right? Because like to do this part, not too bad, and then everyone was like, oh, I'm going to take the derivative of the square root of x squared plus 1. Just write the notation. I'll be like, oh, Andrew knows what he's doing. He just wants to buy himself another step. That's okay. All right, so let's wrap this up with something called the extended chain rule, or depending on how you've been raised, Big Mama.
Ask me.
Somebody's gonna ask me about Big Mama?
No, he's gonna ask you where you got a comma one.
Yeah, he just, he plugged in 0 for x.
Right, so g prime of 0, you're gonna plug in 0 for x, 0 squared plus 1.
The one time you get to say it in class.
Okay, everybody good?
Yeah.
All right, so let's wrap this up with the extended chain rule.
No.
The extended chain rule is what you're gonna do when you have a function living inside of a function, living inside of a function. If we can handle this, then guess what? You can go in as far as you want to. Some people like to call this, like, if the chain rule is like the baby and the mama, some people like to call this Big Mama's rule. Depending on how you raise, you might refer to your grandmother as Big Mama. Maybe you want to refer to this as the abuela rule. It's okay. We want to be very encompassing here. In my house, it would be Mimi's rule. Okay. Okay. Where's the mama?
G.
G of x.
Well,
G of x.
Wait, what's that? Wait.
The mama is the outside function.
Also, F.
F is the mama. And the baby?
G of H of X.
G of H of X is the baby. Well, what does the chain rule tell me to do? The chain rule tells me take the derivative of the mama, and then you leave her baby alone. So take the derivative of the mama, leave the baby alone, and then what? Times the derivative of the baby times the derivative of g of h of x. How the heck am I going to take the derivative of g of h of x?
Change.
It's another chain rule, where now g gets to play the role of the mama, and h gets to play the role of the baby. It is perfect, isn't it? It's also kind of gross to think about your babies having babies. Let's not have that conversation, shall we? The derivative of g of h of x is g prime of h of x times h prime. But don't forget all this stuff in front. Close, close. There we go. So that's the extended chain rule. I am not interested in anybody in this room memorizing the extended chain rule. I want you to just think it's a chain rule.
Why is
And
there
then
a
I do-
third parenthesis?
1, 2, 3, open. 1, 2, 3, close.
Okay.
Yep.
Oh, got it.
Okay. All the friends okay? Tomorrow we're going to start mixing our chain rule together with product rule and quotient rule. It's exciting. We're going to throw in the derivative of sine, cosine, the exponential, the natural log. Don't be absent tomorrow. Okay, we've got a couple of minutes left. I would strongly recommend you use this time to get started on the homework. Start on the homework.